In late August and early September 2025, during training for a Victory Day parade, China publicly debuted a new armored fighting vehicle that has since attracted global attention for its radical design philosophy, broadly similar to concepts pioneered by Russia's T-14 Armata tank. The most notable feature of this vehicle, officially designated by open-source analysts as the Type 100 or ZTZ-100, is the complete concentration of the crew within a heavily fortified armored compartment situated strictly at the front of the vehicle's hull, completely isolated from the unmanned turret structure. This design represents a fundamental departure from traditional layouts, where crew members sat directly inside or beneath the turret, and it aims to maximize survivability against modern battlefield threats such as top-attack munitions and explosive devices. Although the turret is covered with tarpaulin in some transport footage to conceal optical and sensor details, observers believe the vehicle will be equipped with an advanced active protection system featuring four-sided phased array radar, designated GL6. The appearance of the prototype on a tractor truck suggests the project is undergoing active field testing, and its physical dimensions strongly indicate this is China's candidate for a next-generation main battle tank. Based on verified photographs from the 2025 parade rehearsals and official Chinese sources, the Type 100 tank has 6 load-bearing wheels on each side and a combat weight estimated between 35 and 45 tons, making it significantly lighter than the Russian T-14 Armata. The vehicle is armed with an auto-loaded 105mm main gun housed within an unmanned turret, capable of firing APF-SDS rounds at a muzzle velocity of approximately 1,706 meters per second, with a sustained rate of fire around 12 rounds per minute. Some online forums and unverified social media posts have speculated about a heavier prototype with 7 road wheels and a potential 125mm cannon, but as of mid-2026, no official confirmation or clear photographic evidence of such a vehicle has emerged. Therefore, any claims about a 7-wheeled chassis or a 125mm armament remain in the realm of unverified rumor and should be treated with caution. This distinction is important because confusing verified platforms with speculative ones undermines the credibility of any analysis. To understand why China developed the Type 100 crew isolation design, one must examine the ZTZ-99A, which evolved from Soviet T-72 lineage and still uses a mechanical carousel autoloader located on the hull floor. This Soviet-derived arrangement reduces the crew to 3 personnel and allows for a lower turret profile, but it stores the volatile 125mm propellant charges and projectiles in a circular carousel directly beneath the turret basket. A penetrating hit from a kinetic projectile or shaped charge jet reaching this ammunition compartment can trigger catastrophic secondary explosions. When this happens, the explosion often blows the turret completely off the hull, a phenomenon widely documented in conflicts involving Soviet-era designs. This vulnerability is precisely what the Type 100 isolated crew capsule and blowout panels for the turret ammunition storage are intended to eliminate. Older Chinese main battle tanks, such as the Type 98 and early Type 99, feature the JD-3 active laser defense system, which acts as a soft-kill countermeasure against enemy electro-optical sensors. The JD-3 operates by first using a low-power laser to detect and locate hostile laser rangefinders or target designators, then firing a high-power laser pulse back along the same path to dazzle or saturate the enemy's optical circuits. Open-source analysts believe the system is capable of temporarily disrupting or degrading thermal sights and missile tracking sensors, although its exact capabilities remain classified and claims of permanent blinding are unverified. China is a signatory to Protocol 4 of the Convention on Certain Conventional Weapons, which prohibits the use of laser weapons specifically designed to cause permanent blindness, and the JD-3 is officially framed as a countermeasure rather than an anti-personnel weapon. While the Type 100 may incorporate newer hard-kill systems like the GL-6 APS, the legacy JD-3 demonstrates China's long-standing interest in electro-optical warfare. The United States military has consistently rejected Carousel autoloaders, instead maintaining a 4-person crew with a dedicated human loader on the M1 Abrams series. This manual loading doctrine allows the Abrams to store all main gun rounds inside the rear turret bustle, separated from the crew compartment by a thick armored door. The ammunition bunker is equipped with blowout panels integrated into the roof structure, so if an enemy strike detonates the stored shells, the explosive pressure vents harmlessly upward and away from the crew cabin. A skilled human loader can maintain a flexible rate of fire while adapting ammunition selection to rapidly changing battlefield conditions, though modern autoloaders generally achieve higher sustained cyclic rates of 8 to 12 rounds per minute compared to a human loader's typical 4 to 6 rounds per minute. The real advantage of the 4th crew member lies in additional hands for maintenance, observation, and extended operational endurance, not in raw reloading speed. This fundamental difference in ammunition storage philosophy has been a key factor in the Abrams' crew survivability record over decades of combat. The M1 Abrams has used the Honeywell AGT 1500 gas turbine engine since 1980, coupled with the Allison X 1100-3B automatic transmission, delivering tremendous torque almost instantly from a standstill, but consuming immense amounts of fuel even when idling. Chinese main battle tanks like the ZTZ-99A traditionally used diesel power plants such as the 150 HP Series 512, offering better fuel efficiency but slower throttle response. However, the Type 100 reportedly employs a hybrid diesel-electric propulsion system, generating approximately 1,500 horsepower, which allows for silent electric drive at low speeds and reduces thermal signature. This hybrid architecture represents a significant technological leap that partially closes the gap with Western mobility standards while retaining fuel economy advantages. It is important to note that no official confirmation exists regarding the engine type of any rumored 7-wheeled prototype, so any claims about its power plant remain speculative. To understand how modern main battle tanks transfer engine power efficiently to the tracks, engineers look to the hydrodynamic torque converter, a component common to many heavy armored vehicle transmissions. A torque converter uses an internal stator mechanism that multiplies engine torque when the vehicle faces high resistance, acting as a fluid cushion to prevent stalling when climbing steep gradients or pushing through thick mud. Once the vehicle gains sufficient forward momentum, the converter automatically engages a lockup clutch to bypass the fluid coupling, ensuring that 100% of the engine's power goes directly to the tracks. The onboard transmission computer constantly calculates optimal shift points based on engine load, vehicle speed, and terrain resistance, transforming raw engine output into smooth tactical mobility. This technology is not unique to any nation and has been employed in various forms by both American and Chinese armored vehicles for decades. The Type 100 demonstrates that China is aggressively pursuing the next evolution of armored warfare, moving away from the vulnerable Carousel autoloader layout toward a Western-inspired philosophy of ammunition isolation and crew protection. Operating without the space constraints required to sustain human operators inside the turret, the unmanned turret features a hyper-compact, ultra-low profile that drastically reduces the vehicle's physical visibility and thermal signature on the battlefield. Unlike the dangerous carousel placement of the legacy ZTZ-99A, the Type 100's ammunition feed system is physically isolated from the crew cabin and equipped with blowout panels, neutralizing the risk of turret-blowing propellant explosions that have plagued Soviet-derived designs for decades. Whether intended for domestic deployment within elite PLA armored divisions or optimized for the international export market, this unmanned turret prototype proves that China has learned critical lessons from past design vulnerabilities. However, it remains a prototype, and claims of absolute structural and technical supremacy are premature. The vehicle must first prove itself in rigorous operational testing and potentially actual combat.